So we've been talking about the way the hydroxide concentration and the H plus ionization vary. We actually need some numbers to go into some equations at this point. We're going to deal with the fact that if your hydrogen ion concentration, note the square brackets, this means it's in molarity, is 1 times 10 to the negative fourth, we can find out what the hydroxide concentration is because they are always going to vary in relationship to each other. So I'm going to take my Kw value, 1 times 10 to the negative 14th, and I'm going to put it over the piece that I know, 1 times 10 to the negative fourth. Do your division, and you should end up with a hydroxide concentration of 1 times 10 to the negative 10th. So by looking at this, we can tell, since this number is bigger than the answer to my hydroxide, we can tell that this is an acidic solution. Well, that was kind of a nice round number. I had 1 times 10 to the negative fourth. What if I have something that's a little bit messier number? How about if my hydroxide concentration is 0.00037 molar? So definitely a messier number here. I want to find my hydrogen ion concentration. The setup is more or less the same. We've got the whole idea of here's your fixed value, here is your Kw, so that's the one that's going to go on the top. 1 times 10 to the negative 14th. Put the number value that you know, 3 zeros and a 37, do your division, and this one gives you 2.7 times 10 to the negative 11th. So, whereas this one was an acidic solution, this one is a basic solution. I have a higher value for my hydroxide than I have for my H plus ion. So now we need to continue onward down this pathway toward pHs. In the world of chemistry, physics, and math in general, the p is a function. It is the negative log of a thing. So in this case, when you have pH, it is negative log of your hydrogen ion concentration. As you do this, you are going to get values that primarily fall between 1 and 14. Technically, you could actually go down to 0. Actually, if you want to really, really stretch a point, you could go down to negative 1. That's an extreme situation. Normally, we are dealing with things that go from 0 to 14. So your pH scale goes basically from 0 to 6.9 is the acidic end. We've got 7.0 right dead in the middle, and this is your neutral area. And then you've got 7.1 all the way up to 14, and this is your basic end of things. So again, we're talking about P as a mathematical function. If you can have pH, since we've got concentration for H plus, we can also have concentrations for OH minus. So POH is negative log of your hydroxide concentration. So if you add the two of these things together, we get back to a fixed value again. You have pH plus POH has to be 14. If you took the negative log of your Kw, you would find out that this is 14. Because 10 to the negative 14th, take the log base 10 of it, should give you a value of 14. So one last example here. If you are calculating a value based upon a pH, so how about if we say orange juice has a pH of 3.5. We want to find our hydrogen ion concentration. you need to anti-log this. So anti-log, in the world of your calculator, this probably means that you are going to need to do shift or inverse and then hit the LOG button before you put your value in. We also need to make it be a negative value. So you are going to anti-log negative 3.5. This should end up giving you a relatively small answer. 3.16 times 10 to the negative fourth, and that is your hydrogen ion concentration.